Hello everybody, welcome to the shop. I finally got the belts relaced for my Canedy Otto drill press, and I'm really excited to drill a couple holes for you guys and show you how this thing works. I did mention in a previous video that I was going to show you how to lace belts, but I decided against that because I didn't really want a situation of the blind leading the blind. I've never done it before. This is the first time I laced belts. It came out just fine, but if you really want a good video on how to lace belts, check out either Mr. Pete 222 or Keith Fenner. They've both done very good how-to belt lacing videos. So, you know, I pride myself on making good content, not just content, so I decided against making a video about belt lacing. But the belts are nice and tight. I hit them with a wire brush on the friction side to kind of rough them up a little bit, get that glaze off, and they seem to grab really well. So, as you can see, I've got my studio set up here, nice backdrop, and let's lubricate this thing and get it going. So there's 2 oil cups up top on the main drive shaft. There is also a lubrication point. If I were to move this belt, there's a screw that I would remove, and I would lubricate the shaft inside here that lubricates the back gear shaft assembly, but I have already lubricated that, and that will only require periodic lubrication, so I'm going to leave that alone for the time being. The bevel gear also has an oil hole here. Whoops. Put a drop of oil in the back gear eccentric. And I'm just going to go in here and put a squirt of oil on the back gears themselves. The pinion gear shaft has an oil point on either side. That one's a little tough to get to. Then the power feed shaft has 3 oil points. I'll also mention that I added all these oil cups. Of course, as you can see, they're new. Originally, this machine just had holes that you would stick an oil gun into, oil can, and lubricate it. And I didn't like that because dust can enter the hole and wear out your bearing prematurely. Even though I'm sure these are original bearings and it's 100 years old, so I don't think there's any wearing out that's going to happen, but still, that's just what I wanted to do. On the power feed input drive shaft, there are also 2 oil cups. And then on the bottom drive, there are also 2 oil cups, 1 on each side. Now here is the piece I'm going to be drilling through with just a piece of scrap. See, it's quite thick, maybe 5/8, 3/4 thick or so, plain old carbon steel. We're going to do this operation in 2 steps. First with a pilot hole, I don't know what size, this is maybe 1/4 inch or so. And then the final drill bit, which is 1 inch. And I just sharpened this drill. I ran a test cut and one side was cutting a little bit hotter than the other. I touched it up. Hopefully each side of the drill bit will cut evenly and it'll twirl off 2 nice heavy chips. So drilling these 2 different size holes will require 2 different speeds. This one will require a fast speed and this one much slower. So for this drill bit, let's put the drill into the highest speed possible. So first I'm going to move the belt from the smallest pulley on the bottom and the largest on top to the opposite, where the driving pulley will be the large and the driven will be the small. You do that by hand, just by kind of rolling it off of the pulley. Just pull the belt towards you a little bit. Get it off, now it's loose. So I'll place it on that desired pulley and then just walk it on. There we go. Also, currently I have the back gear engaged, and you could tell that by this pin being stuck out. So I will disengage back gear by turning this pin till it clicks in, pulling the lever out, and give this a rotate until this gear clicks in. Like that. Now this shaft is directly engaged to that shaft here. This is the power feed belt. It is currently on the slowest feed rate. See, it's on the smallest pulley on the driving side and the largest pulley on the driven side, and I'm going to keep it that way. Okay, so I got everything clamped up and chucked up. Now I have to admit, I guess my main drive belt isn't as tight as I thought it was yesterday. It slipped when it was on the fastest speed, so now I have it on the second fastest speed, and I don't think this small drill bit will have any problem, you know, putting on too much load to make the belt slip. So let's fire it up. So let's engage it. Cut through the metal, disengage the power feed. Now I'm going to put it into the lowest gear for drilling the large hole. I'll engage back gear by pulling out the locking pin and rotating it so it stays out, and then engaging the back gear lever like so. And that's about as slow as she goes, ladies and gentlemen. I would estimate that to be maybe 60 RPM or so. Engage the power feed. You can see how slowly the lowest speed will advance that spindle down. Of course, it's advancing at the same depth per rotation as it is in high speed, but everything is just slowed down now. Now, as you see, the drill bit is still a fair ways away from the work, so I'm going to show you an interesting feature that I kind of discovered when I was working on this. There's a ratchet pawl on the back side of this shaft that I pointed out in one of my previous videos, and that purpose is so even with power feed engaged like it is now, you could advance it by hand while it's spinning. So let's say you start the power feed with the tool too high up away from the work, you don't have to disengage the power feed and feed it down by hand. And you just turn it in the direction of rotation. And you can hear that clicking, that's that ratchet. And you could see it advance faster if you look at the graduations here. There's a nice curly Q. Okay, we're just cutting wood now. We're all the way through. Disengager. I also could have set this stop down here and it would have automatically disengaged it, but I really don't have to do that. There you go, folks. One drilled hole. Some nice chips to go along with it. You can hear them clank pretty well when you drop them. So that's it. That's the moment we've all been waiting for, or at least that I've been waiting for. I'm excited to see it run. Still need to tighten up that main drive belt a little bit apparently. I'll put some more lacing in it this coming weekend probably. But it works well enough, especially at low speed. There's so much torque from the gear reduction that you don't really notice the slippery drive belt. And that's that. I think it will be an excellent addition to the shop, especially I think with hole saws. I think that'll be where it really shines, because there's plenty of times I'm drilling a 3 or 4 inch hole with a hole saw, and the Craftsman drill press 500 RPM really just doesn't cut it. This will be just right. 50 RPM, 100 RPM, perfect. So that's it, everybody. Thanks for watching. Make sure to give me a thumbs up if you enjoyed this, and hit the subscribe button. You know the drill. And see you next time.